Welcome to Excellence Link Academy. In our previous class, we discussed about strength of material, and also we discussed about the base technologies in strength of material, and we explained the technologies one after the other, and we did some calculations, and we said that we established that deformation comes in two forms, right? Either what the contraction or elongation. So and also we discussed the concept of what tensile and compressive stress, right? For tensile, the arrow goes what outward. For compressive, the arrow what goes inward. All right, let's treat some past question on strength of material. This past question is for civil engineering. This is for civil engineering past questions. All right. So let's take this down. Please put out. A steel bar is 900 millimeter long. A steel bar is 900 millimeter long. Its two ends, its two ends are 40 millimeter and 30 millimeter in diameter. Full stop. I said a steel bar is 900 millimeter long. Its two ends are 40 millimeter and 30 millimeter in diameter. Full stop. The length of each end is 200 millimeter long. The length of the two ends is 200 millimeter long. Full stop. The middle portion of the bar is 15 millimeter in diameter. The middle portion of the bar is 15 millimeter in diameter. If the bar is subjected to an axial tensile load stress, if the bar is subjected to an axial tensile load stress of 15 kilonewton, comma, find the total elongation. Find the total elongation. Find the total elongation taking E, your modulus, E to be 200 giganewton. Take E to go there 200 giganewton per meter square, right? This is your modulus. So take E to be 200 giganewton per meter square. Alright, so I'm giving your modulus to be 200 giganewton per meter square. So first is first. The first part is what? Write out the given parametric units. So what are we giving from the question? From the question, first is first. I was told that a steel bar is 900 millimeter long. Now observe something, please. I'm told that a steel bar is 900 millimeter long. It simply means the length of the bar. Let's say for instance, this is the bar. If I had a bar this way, for instance, this is the bar, a bar in this section. I'm told that the entire length of this bar is 900 millimeter. No stress. Now, 900 meter long. Its two ends are 40 millimeter and 30 millimeter in diameter. Now listen, this is the first end and second end, right? I'm told that this end here is 40 millimeter and this is 30 millimeter. Now, question is that it is 40 and 30. Are they going to be in the same height? Obviously no. So hence, in that case, let me say this is 40. Now for 30, let me say this is 40 here. Let me say this is 30 here, right? For 30, the height will reduce, right? So let's say this is 30 in this case. So this is 30. This one is diameter of 40, diameter of what? 30. Alright, I'm told that the length of each end are 200 millimeter long. The length from here to here is 200 millimeter. Also, from here to here is what? 200 millimeter. The length of the two ends of the bar is 200 millimeter. Also, the middle portion of the bar is 15 millimeter in diameter. Now listen, here is 40 millimeter in diameter, here is 30. For 15, 30 and for 40 and 30, 15 was smaller. Hence, I will clean this part. Listen, no, and I'll clean this part this way. So for 15, I'll have 15 at this section. Why? 15 is smaller. So hence, this is like the imagination of the question given to us. This is the bar they're talking about. So the middle portion of the bar is what? 15 millimeter in diameter. If the bar is subjected to what? An axial tensile load. For tensile, the arrow, are they going outward or inward? They are going what? Out. Alright, so the C bar is actually what? Tensile. So I'm told that what? I'm having what? A tensile load of tensile load stress of 15 Newton. So for tensile, the arrow are going outward, 15 kilonewton, 15 kilonewton. Now listen, here's a little concept here. I can go ahead and start solving the question, but to make my work different, it's actually I need to draw the diagram, right? If for instance they're doing this question in the exam center and all of you just went ahead solving, this is different to make to make the work different from others. So we try to sketch out the diagram that the person is actually what talking about. So now my first task is that I will list out my what given parameter. First, I'm given. Now listen, let's draw this diagram back. This is the diagram here, right? So if you're trying to draw this in an exam sheet, you try to draw it in a rough part before you put down this into your question. So let's look at the question. Let's look at the diagram. So this is my diagram. This is the bar coming 40 millimeter. This is 15 millimeter in diameter and 30. Right? This is my bar this way. I'm told that this is what diameter of what 40. This is what diameter of what 30 in diameter. These are the dimension in engineering, right? So I'm given this to be what 15 diameter, right? The length here is 200. The length here is what then? 200. Obviously, I'm told that the distance from here to here is what? 900. So hence, my middle portion here is what? 500 millimeter, right? So I'm told that what? A tensile stress load of what? 15 kilonewton, then what? 15 kilonewton, right? So this is my diagram. From the question, I'm given that my first task is that I'm given 3 diameter. So diameter 1 is what? Diameter 1 is 40 millimeter, which is this. Diameter 2 is what? 30 millimeter. 30 millimeter, right? And diameter 3 is what then? 15 millimeter. Now listen, your next task is that look at this bar. I've sectioned into what? 3 portions, right? Let's call this portion 1, 2, and what then? And 3. So section this way. Now I have diameter 1, diameter 2, diameter 3, right? So I'm given those diameter, and also I'm given what? A tensile stress. Tensile stress, right? I'm given a tensile stress of 15 kilonewton. A tensile stress of 15 what the kilonewton. Let's call it the force, perhaps F, 15 kilonewton, right? I'm also given what the a tensile stress of 15 kilonewton. I'm giving you modulus E to be what? 200 giganewton per meter square. So the first time is that how do you solve this? Where do you start from, right? So first things first, I'm given diameter for each sections, and I'm given what? Force, tensile stress of what? 15 kilonewton, and I'm given what? Young modulus to be this. Now after this parameter, what do you check for? Are you converting? Obviously yes. If this is meter, I'll convert this to meter, right? This is kilonewton. This is giganewton. convert giga to kilo, right? So now let's convert this first. Let's convert this. I have E to be 200 giganewton per Alright, so I'm giving numbers for 200 giganewton per meter square. Giga is 10 to the power 9, right? I have giga is what 10 to the power 9. So hence I will express this as saying 10 to the power 6 times 10 to the power 3. Obviously, if I add this together, I will have 9. So I'll take this back. I'll have E is equal to 200 times 10 to the power 6 times 10 to the power 10, this to the power 3 Newton per meter square. Obviously, E is now equal in value to. My aim is to convert giganewton per meter square to what? Kilonewton. Hence, I have 200 multiply 10 to the power 6. This is 10 to the power 3. Naturally, kilo is what the 10 to the power 3. Hence, I'll replace this what with kilo. I'll have kilo Newton. This is the Newton here per meter square per meter square. Obviously, now I've converted my numbers to be this. So I'm not using this again. I'm using this now. Also, I'm given diameter of 1, 2, 3. I'm also given the length of section 1 to be what the 200 millimeter. Length of section 2 to be also what 200 millimeter. Obviously, the last section 3 is what 500 millimeter. So these are all the first. These are the first tasks here, right? These are the first tasks. Now listen, please. Having converted the modulus, I would like to convert what my diameter and my length to what to meter, right? To have what uniformity of parametric units. So now if I do that, if I do my conversion, if I divide all through, if I divide this by 1000, I'll have 0.04, right, in meters. This one I'll have 0.03 in meters. I'll have 0.015 in meters. If I convert this to meter, right, kilonewton, no problem. I'm having meter, then what the meter. Convert all this to meter, I'll have 0.2 meter, I'll have 0.2 meter, also 0.5 meter. Simply divide by what? By 1000. Alright, now no problem now, I can now start solving. Listen please. Our first step was that from the question, we drafted a diagram. Having considered diagram, we section all the parts, diameter of 40, 30, and 15. Having done that, we told that the bar is what has about tensile stress of 15 kilonewton. So this arrow indicates what the tensile. I would say tensile, the arrow was going outwards, right? So that's that. I'm told that distance from here to here is what 200, 200. The middle part is not given. But we are told that the entire length is what 900. Hence 400 minus 900, I have what 500 length. So I have all this. So the question we are told that we start with what the total elongation. Total what the elongation. Hence we know that elongation initially is equal to what Fm over AE. And I have what 3 sections here. Hence, my total elongation, recall, total elongation will be equal to what? Elongation at section 1 plus elongation at what? Section 2 plus elongation at what? Section 3. Hence, in that case, for section 1, I will have what the Fn over AE, but observe please, N for length of section 1 and what area of section 2. Observe please. Listen, for the force and the modulus, for each section I'm using the same force and the same modulus. But what you use there is what the length and the area here, which is this. So this for elongation section 1 plus At section 2, I'll have F or FL or F2 over what there? A2E, I have this, plus at section 3, I'll have the same L3, FL3 over what there? A3E, this way. I have all this way, this format. So hence, I need to know force. I know my force, which is this, 15 kilonewton. N1 is given to be this, which is this. Area section 1. Now listen, in science, if you are given diameter, obviously you can get the area by applying the formula called pi d squared or 4. So let's convert this diameter to what? Area, because we don't need diameter here, we need what? Area to get our answer. So area section 1 is equal to what there? Pi d1 squared over 4. Listen, area section 1 is what? Pi diameter section 1. Area section 1 goes with what? Diameter section 1. So it's equal to pi is what there? 3.142 multiply diameter section 1 is what? 0.04. I have 0.04 all squared all over 4. My final answer here for area section 1 will be equal to 1.26 multiply 10 to the power minus 3 meter squared at section 1. Now listen, I need to get area section 2. So area at section 2 is equal to pi d squared, pi d2 squared over what then? Over 4. Pi is what? 3.142 multiply diameter section 2 is what there? At section 2 is 0.03 is 0.03 all squared over 4. My final area here for section 2, area section 2 is now equal in value to 1.77 multiply 10 to the power minus 4 meter squared, right? Make sure you punch your value and get your answer, right? Also, I need to get what? Area section 3 is equal to pi d3 squared over 4. Pi is what there? 3.142 multiply diameter section 3 is what? 0.015 all squared over 4. So my final area here, area section 3 will be equal to 707 times 10 to the power minus 4 meter squared, right? So ensure that your unit is what? In meter squared. So I've gotten my area now. Now listen, for section 1 alone, section 1 here, my force is given, which is 15 kilonewton. N1, I know my N1 to be this. I'm given area section 1, I've gotten my value for area section 1. E is given to me what? This. So hence I can find for section 1. For section 2, check, I'm given a force 15, no stress. L2 is given, I'm given L2 to be this. Am I given A2? Observe, A2 is here. Am I given E? Obviously yes, which is this. I can find for section 2, right? Section 3 now, check, F is given 15 kilonewton. L3 is given to be this. Also, A3 is this. E is given to be this. So obviously I can what? Find for what? Total elongation at this point. So when you start parameter this way, it tells you where you are going and what you need to do. So which I'm able to illustrate this way now. Now there's something in mathematics. You can see that F and E are the same. F and E are the same. F and E are the same. I can factorize them out, right? So in that case, my total elongation is going to show this place. So total elongation, ET now is now equal to, observe please, F and E are common to everything. Bring out F and what then, and E, all into L1, A1. I'll have L1 over what then, A1, positive L2 over A2, L2 over what then, A2, plus L3 over A3, L3 over what then? A3. Observe please, if I multiply F over E times L1 A1, I will have F L1 A1 E. If I multiply this with this, I'll have that part in the middle there. Multiply this with this, I'll have this, which is still correct. Now at this point, I'll just plug in my values. If I plug in values, I'll have F was given what? 15 kilonewton, right? So this 15 kilonewton all over E. E is what there? 200 times 10 to the power 6. 200 times 10 to the power 6. All into L1. Check. L1 is what? 0.2. 0.2 all over A1. A1 is going to be 1.26 times 10 to the power minus 3. Positive, I have L2. Check, what's L2? 0.2. I'm having 0.2 all over A2. A2 is given to be 1.77 times 10 to the power minus 4. I have a positive sign. L3, check. What's your L3? 0.5. I have 0.5 all over what's there? A3. A3 is what? 7.07 times 10 to the power minus 4. So I'll plug in all my values now. So what do I do now? I need to start punching, right? So if I punch my values, now listen please, listen please. If I punch this one, the 2 here, I'll have that, I'll have total elongation is equal to, if I divide between by this value here, obviously I'll have 7.5 times 10 to the power minus 8 this way, right? If I punch all this value here, everything here, right, I'll have my final answer there to be 1.62 times 10 to the power minus 3, right? So multiply these two together. So my total elongation will be equal in value to 1.215 times 10 to the power minus 10 in meters. So here's my answer to that question after solving. So now listen. The first task from the question, draw a diagram. What you are imagining, what you are citing from the question you have read out, which is this. This is the bar here, right? Section it. Then what? What your given parameter, convert them. Now listen. For the conversion, instead of material, conversion is bloody, right? It's bloody. Now, let's not something, please. Know this, please. Kilo, mega, giga, and tera. For kilo, 10 to the power 3. For mega, 10 to the power 6. For giga, 10 to the power 9. For tera, 10 to the power 12. So if you are converting, observe this stuff. Initially, I was given the modulus to the what? Giga. I had to convert to kilo. And kilo is 10 to the power 3. If I did, giga is what? 10 to the power 9. If I remove 10 to the power 3 from it, I have 10 to the power 6. That's what I'm having here. Then this is what? 10 to the power 3, which is kilo now. So that's how to convert, please. Conversion might be bloody to the material, please. That's the difference between material and physics, right? When it comes to conversion, trust me, it's confusing, right? So just understand the basic concept. The way I converted this, know this, please. So in case you want to convert any parametric units, right? So let's do one more example. Past questions. This is for mechanical past questions, right? So let's solve them. Let's call it a day for the material. Alright, example 2. Example 2, put on this. In a tensile stress run, in a tensile test run, comma, the yield load is 130 kilonewton. The yield load is 1303 kilonewton. I'm given the yield load to be what then? 130 kilonewton. The ultimate stress is 7900 kilonewton. Ultimate stress, I'm given what? the ultimate stress to what the 7,900 kilo Newton, and the 700 kilo Newton. If the diameter of the circular bar is 40 millimeter, diameter of what the circular bar is what 40 millimeter. I said in a tensile stress run, the yield load is 130 kilonewton. The ultimate stress was 7,900 kilonewton per meter. Sorry, kilonewton. Okay, per meter, please, per meter. Kilonewton per meter squared, rather. Per meter squared. Given diameter was 40 millimeter, and diameter was 40 millimeter. That's all. So number one, calculate what? Maximum load. Right? Number two, calculate what the tensile stress. Tensile stress. And lastly, okay, that's all. Alright, let's solve this, please. What the first task, please? Listen, I'm given yield load, I'm given ultimate stress and diameter, right? And I'm taught to find what maximum load and what tensile stress. So what will you do? Now, are you converting in this case? Obviously, yes. I'm given tensile stress, ultimate stress what? Meter. Convert this to meter, I'll have what 0.04 meter, right? So solution. Now listen this. Solution. I'm talking about maximum load. Maximum what? Maximum load. Now note that ultimate stress. Listen please. Ultimate stress is equal to what the maximum load over area. Note that, recall that ultimate stress, let me put this way, this is stress. So ultimate stress is equal to what the maximum load, right? Maximum load is F. Maximum load over area. Please, maximum load over area. So let's compare the diameter to area. So area is equal to by d squared over 4. Converting diameter to area. So that becomes what then? 3.142 multiply, this is what? 0.04 all squared all over 4. My area at this section will be equal in value to area at that section will be equal in value to 1.26 multiplied 10 to the power minus 3 in what then? In meter squared. So obviously, ultimate stress is equal to what the maximum load over area. Load is represented with F or P. So in this case, I use F. I use P. So maximum load over area. I'm going to calculate for what? Maximum load. At this point, over 1. Cross multiply. I'll have maximum load. Fm, or perhaps maximum load, is equal to what the ultimate stress multiplied by area. That's ultimate stress multiplied by what the area. So maximum load is equal in value to what? Ultimate stress. Check. Am I given ultimate stress? Ultimate stress, because I'm given is what the 7,900 multiplied area is what? 1.26 times 10 to the power the minus 3. My value there, my ultimate stress now, maximum load now, or perhaps Fm will be equal to, if I multiply these two values, I'll have 89.334 Newton, right? Maximum load. Load is in kilonewton. So I have maximum load to be this. So question 2, let's do question 2. This is question 1, right? For question 1. For question 2, tensile yield stress, right? Tensile yield stress. So I can call tensile yield stress to what then? Tensile stress or tensile yield stress is equal to what then? Yield load over area. That's the formula. So yield load all over area. Now, on tensile stress now, tensile stress or tensile yield stress perhaps is equal to yield load. Am I given yield load? Obviously yes, 130. That's 130 all over area. What's my area? Area is what there? 1.26 multiply what there? 10 to the power minus 3. My final answer, my ultimate stress, ultimate yield stress is equal to 103.17, right? Kilonewton per meter squared. Why? Stress. You say stress is what? Force over area. Force is in Newton, kilonewton, and area is what? Meter squared. So this is my SI unit here. This is what the ultimate. This is load, force, kilonewton. That's kilonewton as my SI unit here. So this is how to solve problem on this concept here.